Good morning, 11th grade. Please wish your mothers a happy Mother's Day today. I am making this video on the 10th, Sunday the 10th in the morning. Hope you're doing well. We have just a couple more weeks left in school, so stay strong, keep working. This video is to help you understand what is on the quiz. We're just a selection of some review problems. First of all, here are the formulas that you'll be given or that would be useful when taking the quiz. The first two questions on the quiz review are graphs of exponential equations, and you can see on the left just this pattern is going down, and so this would be a decay, but then on the other side, when we move it from left to right, we're increasing, so this would be decay. Now, to get the equation, we have to use the points on the graph. So what you should do is create a table of values from the graph and see the pattern of the growth or decay. So let's look at those patterns. So notice the red graph. And then this one is K. Okay, so the decay comes from looking at these points, just picking these points off of the graph, and notice that the ratio is all the same, 1/2. 8 divided by 16, 4 divided by 8, 2 divided by 4, 1 divided by 2. All of the points within this graph follow that same pattern. And our starting value in this case is the 0 term, so 0 term is 4. So it becomes y equals 4 times 1/2 to the x power. And the second one is done in a similar manner. The next set of questions asks you to find the common ratio, the 8th term, and the explicit formula. Well, the explicit formula is right here. This is the explicit formula, also known as the nth term. So there's your explicit formula, and that's what we will be using to model the patterns. So this first one, notice that it is alternating negative, positive, negative, positive. And when we find the ratio, we see that it is a -4. And then that -4 is your constant multiplier. So that is right there. And then our first term is -2. So that first term goes there. And then the second one is found the same way. And then once you have that formula, if you're trying to find the 8th term, let's find the 8th term here. You plug that 8 into your equation. And what's 8 minus 1? 7. But then apply the exponents. But be careful. -4 is the only value that's being raised to that 7th power. So take -4 to the 7th power, then double it. Multiply it by -2. Now the next question asks you to find the missing terms. Excuse me. Well, what we have to be very careful with is recognize how many multiplications there are from this first term all the way to the 4th term. Here's the first, second, third, 4th term. When you look at that multiplication, we know -3 times some number gives us the second term. So that second term is right here. Second term. Then your third term comes from multiplying one more r, one more multiplication. And then lastly, to get to this final number, 648. I'll make it brown. There we go. That negative 648, we have to multiply a third constant multiplier. So there are 3 multiplications between the first term and the fourth term. So when we divide negative 648 by negative 3, excuse me, we get 216. And then we notice that that is raised to the third power for the 3 multiplications of that constant multiplier. So we need to take the cube root. So when we take the cube root, we get 6. And so then what we do with the 6 is multiply it to negative 3, and then multiply it again to get the third term. So negative 3 times 6, negative 18, and then negative 18 times 6, negative 108. And the other pattern in part B follows the same idea. Again, there's 3 multiplications between the first and the fourth. But if we had the second term and say the seventh term, how many multiplications? And if you said 5, you are correct. So always keep in mind how many multiplications you have between the terms you are given. Okay, let's look at some IB questions. Here we have the 7th term and the 8th term, and those are consecutive. So to write down the common ratio, all we have to do is divide that 8th term by the 7th term. And then we need to work backwards to find the starting value. Then use that starting value and your constant multiplier, put A and B together, put A and B together, and you'll get part C. Then in part D, you could simply just find all 10 terms and add them up, or use the formula. Here's that work. So our constant multiplier is 1/3. And using that 1/3 in part C, we see the constant multiplier, and the exponent is n minus 1, because that 78,732 is your first term. Just had to go back and find that. And then to find the sum, you can use the sum formula. I'm going to go back to this first slide. Here is the sum of a geometric sequence. You can use this formula. All you need is the starting value, the number of terms, and your constant multiplier. Once you have that, plug it in, and what you're doing is just adding up all those 10 terms. The next question is about the number of cells in a culture, and T is time, and then C tells us how many cells are in that culture. We need to write down 2 equations using this information that's bolded. So number of cells in a culture at 12 o'clock on Monday is 47. Well, how many hours is that away from 12 o'clock on Monday? That's a case where T equals 0. And then down below in the second part, how many hours is 1600 past 1200? Yep, T equals 4 hours. And so with that information, you have 0 and 47 and 4 and 53. We can now write down 2 equations in terms of P and Q. Notice we don't have the starting value and we don't have the asymptote. And then we'll use that equation to find out how many cells in the culture at 2200 on Monday. And that is the case where T equals 10 hours. Let's look at those solutions. So here we plugged in 0, and then over here we plugged in 4 to generate two equations. There's 1, there's 2. I used substitution. You could have used elimination. You could have used your graphing calculator. And you could have also used matrices if that is something that you are familiar with. Using any one of those methods, you'll come to a very small p-value and a value of Q that's very close to 47. In part C, again, 2200 is 10 hours. So once you have the P and the Q, plug them back into the equation and substitute 10 for your time, and you get over 7 billion cells. Excuse me. The sixth question talks about a car depreciation. And when you look at this equation, remember the starting value is that initial cost. So writing down the value of the car when it was first bought, look to your equation. And then 1 year later, the value was 27,200. Notice that it's less. We need to find the value of R. Well, that's easy. We just divide the two. And then in part B, we need to do a little bit more work and find out how long it will take for the car value to reach 8,000. We can do that a couple different ways. So first, let's take a look at, we wrote down 32,000 for the value of the car when it was brand new. And then we take the current year divided by the previous year. So here is year 1 divided by the initial cost, and we get 0.85. That means the car is depreciating by 15%. It's going down 15% of its original price every year. Now, when is the value going to be 8,000? Well, to get that time, we take 8,000 and plug it in place of our value. And here's our equation model. First thing we need to do is to divide both sides by 32,000. We get 0.25. Now here's how we could use it with logs. You could also use a graphing calculator and find out when y equals 8,000 and y equals 32,000 times 0.85 to the x power, find their intersection. There's a video in the video section that you could watch. Additionally, here is using the change of base formula. There's also a video to learn how to do this. If your calculator does not have the log base function in the math symbols right here, say if you went to math and you found log base, then you're good. You can use that. But if you don't have it, then you will just be stuck with this log key on the front, and that's okay. It's a very slick trick. So we'd take the log of 0.25 divided by the log of 0.85, and we get about 8.53. So about 8.5 years, the value will be 8,000. Here's the last question of the review. This equation gives us the amount of a radioactive material held in a laboratory over a number of years. So again, look to the equation to find the original or the starting value that you're being asked for. So what was the original mass of the radioactive material? 90 grams. And then they give you a table of values. And notice that we're missing one of the y values, the mass values. So in order to find it, we need to plug in 80. And then in part C, we have to work backwards again. So let's take a look at those solutions. First of all, we see 90 grams. I did a little work here to show that when you plug in 0, you get 90 grams. You don't have to show that work, but this is why it works. Now, when the time was 80 years, remember that table, 80 years, we take that 80 years and plug it in for time. Be very careful with your order of operations. First thing you do is exponents. Negative 80 over 20 becomes negative 4. Then from there, apply that negative exponent. 2 to the negative 4th power is the same as 1 over 2 to the 4th power. And what's 1 over 2 to the 4th power? That's 1 over 16. So once you apply that final exponent, what's 90 times 1/16? That's the same as 90 divided by 16. And you get 5.625 grams. Feel free to write it in 3 significant figures as 5.63 grams. Now this last part, how many years will it take to reach 45 grams? Well, if you go back to that table, that's somewhere within this data, right? Somewhere in there. So let's work backwards. How many years? Take that 45, plug it in for our mass. Then we need to divide both sides by 90 to isolate our exponential pattern here. Then from there, we need to look at logs or plug it into your equation, into your y equals. If you're using your graphing calculator and you don't want to use logs, do y equals 0.5 and y equals 2 raised to the negative t over 20 power. I would encourage you, when you're in your graphing calculator, to put this exponent in parentheses so the calculator knows that the t and the 20, or t divided by 20 is the whole exponent. And then find the intersection of those two lines. Or, I'm sorry, this would be a line and this would be a curve. If you're using logs, I use the change of base here, but you could easily plug this part in log base 2 of 0.5 if you have the log base function on your calculator. And then whatever that value is, you're going to have to multiply it by negative 20 to solve for the actual t. If you use the log base, you take the log of 0.5, log of 2, divide those, and you get negative 1. Well, negative t over 20 is the same as negative 1, so that means t is 20. Just multiply both sides by negative 20. Thank you for watching this video, and I hope you have a great Mother's Day.